I mean, it's like, that's like the cool thing about it is because it's always just kind of random. You never really know what's going to happen with them. It's always something new every time. Why does this load so much faster? Huh. Okay. I was at a coffee shop this morning and I looked up some research shit and actually gave myself a little task thing of like what I need to accomplish to log me out of my Notion. What the hell? Come on now. Right there with you. Although this is just hemp for like joint pain, anxiety, all that fun jazz. I usually save the good stuff, the devil's lettuce stuff, for way, 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 way later. Or else I'm useless. That's kind of the thing. Okay, so let's see. So I was looking at some... Basically, I was organizing my research a little bit better, so just in case anyone is curious, I organize all of my research... Oh god, it went black. I organize my research on my Notion. So Notion's just like a note-taking app. But I was trying to figure out... There's this problem I have with one of my... Oh god, where did I put this? Did I put it in phylogenies? Yeah. So I have these two phylogenies. So just, you know, how are... Basically telling me how are all the amphibians related, how are all the lizards and snakes related to one another. And I need to combine them together, but that's been proving a little bit... There's an easy way to do it that is incorrect, and then there's a right way to do it that is a pain in the ass that I'm trying to learn right now. Luckily, I found a nice little guide, so that's what I am working on at the moment. And I'm doing all this in R, so I am currently needing to create a new script. Yeah, on the YouTube side of things, you actually can see all of this a lot more clearly. But yeah, just so you see what I'm working on. So basically, this is my typical research setup. Usually I have Notion up on one side because this is where I keep track of all of my tasks, my projects, my write-ups, everything I need to do. So this is all of my, you know, shit to do for this project right now. And then I have my R Studio up on the other end, which is always fun to look through. But yeah, so I need to combine them together. It's called grafting. Same thing like how you can, like in real life, you can graft two trees together where you like take the limbs of one and put like plums on an apple tree. It's the same thing with phylogenies. You graft them together, but there's some special considerations we need to do whenever we graft things because, the fuck was that? Okay, anyways, have an update, I guess. But yeah, so the way this will work is I can see chat. You can ask any question, anything at all. That's, you know, just how we'd run these. That's how we run these. Okay, so let me see. Can I keep chat up? I want to be able to keep chat open while OBS is relatively hidden. But it won't stay up like the way I want it to. Maybe I can keep chat up here. Always fun to organize all this shit. But yeah, it's an interesting day of trying to get all of this put together, trying to make sure all of this looks good. Because, Jesus, I got so much I need to finish up with this thesis. Let me see here. Okay. But yeah, I hope everyone's day is going good. I am just going to be really hyper-focusing in on this. Okay, OBS is just going to have to be up at the top with Notion up to the side. For some reason, vertical screens are not working near as well as I thought they would. The windows have problems auto-fitting things. But yeah, so basically I need to write up a new script that is going to graft these two phylogenies together. So let me... Okay, so right now I'm just binding the tree. So let's create a new R script. Let's see if there's a way that I can show this a little bit better. Oh, I wish also that sorry, not R, Instagram let me do the dual thing. There's a way to, oh, sorry, that just turns off the video. But yeah, so we're gonna do a new R script. I'm gonna try and narrate over this best I can, of course. But really, let's write out the purpose of this R script is graft graft the two phylogenies together. I'm going to focus it more like this way because I just know that it's a little bit better. I'll show you all major steps. But yeah, feel free to ask any questions. Feel free to ask anything about anything. This is how we're going to do this. I'll try to explain what I'm doing, and then if there's major steps, if we get results, I will show them. So this is the first time I'm doing this dual stream. Like I said, I'm live on the YouTubes right now, trying to make this all work. But the way we're going to graft the phylogenies is I found a guide that's called just Grafting Phylogenies, and they found a paper that grafted, that combined the phylogenies for fish, amphibians, squamates, birds, and mammals. So this is the guide that I'm following right here. It's on some dude's GitHub or Cecina's GitHub. Dude is, you know, regardless of gender to me, and sex, blah blah blah. But yeah, so basically I'm trying to recreate this, but only with the amphibians and the squamates. So amphibians, squamates being lizards and snakes. So I have both of these phylogenies, and I'm actually using very similar ones. But the way they're doing it, it's actually really simple. So they're creating a backbone tree. Like this is the backbone, where it shows the different splits between the different groups. And what I need to do then is basically just do it for these two, amphibian and squamate. And they're doing it pretty simply. So they have, where are they getting these edge lengths from? This is the part that I need to do. Oh, okay, so they're just getting edge lengths from time tree, which just tells you, basically this is like, when was the last time they all were, you know, when did they diverge? When did these two species diverge? So, what I need to find is, okay, what are my steps? Let me go into my Notion. Let's organize up these steps a little better. So the basic steps are going to be, oh, actually, this is a done. This is also done. Realize there's a few tasks I can complete. So the first steps are figure out the basics of each phylogeny. I just need to go through my two phylogenies that I have and double check if they are both time calibrated. I'm almost certain they are, but I need to double check. I need to double check if they have any major issues or if there's any weird things. So note potential issues. Then I need to create a backbone phylogeny, which is easy enough, and then create the time splits for each. So it should be relatively straightforward. Oh yes, I need to make sure they are consistent in their length measurement. Because I'm not sure if the lengths they have for each of the phylogenies are based on time, evolutionary distance, or what. So I just need to double check all of that. So yeah, there's like little things I just need to double check with each. And I need to smoke a little hemp, calm those nerves, calm those body labels. Hello, people who are just joining. But yeah, this should be relatively straightforward. It doesn't seem like it's that crazy difficult. I just need to put them together. So let's start with the first. Let's start taking notes on each of the phylogenies that I have. So I need to open up, actually I might have it up on, oh come on, the history should be synced between the two. Oh no, it's not showing up. Damn. Unless, no. Ah, okay. I had some links up, but I can find it. So I have Jets and Pyron phylogeny. I just need to pull up the papers that I have. Boop. Luckily, both of these can be accessed via Sci-Hub pretty quickly. So boom, and then I need a second one, duplicate, where we are going to do a squamate phylogeny. And I'm trying to remember which one I was using. It wasn't the Weens. Was it the Simoes? Simoes. Did I use this phylogeny? Why? I don't want to log in just to view it. Like, just let me... Okay. So, I think I have it... Right, it was the Zhang phylogeny. There we go. So let's... Why? Stop logging me in! I do not want to log in. I don't want to log in. I just want to view the paper. Come on now. Like, I just want to view the paper. Okay, so then copy link. That's what we'll do. And then let's upload these two phylogenies. There we go. Yeah, so basically I have a phylogeny for squamates. Big species one. And then I also have one for amphibians. So, in my Notion, I have a... Let me see, I have some notes over this. Phyloregions, here we go. Notes, phylogenies, here we go. Okay, so amphibia, let's just add in this link. Cool, so I got my amphibian phylogeny. Boom. Let's do basic stats. Okay, so we have here, boo. So here, I'll show you what I'm looking at right now. So basically, I'm just looking at this paper, oh good lord, which is a big old amphibian phylogeny. They did some really cool methods for it. And I am trying to note down all of these methods. So there's that beautiful phylogeny that has a bunch of colors with evolutionary distinctiveness, right? That's what they're referring to, ED, or is that evolutionary distance? Evolutionary distinctiveness. Okay. Cool. So let me get into their methods, because really I'm just trying to do methods right now. Okay, cool. So they use Pastis, complete data methods. We used AmphibiaWeb. They had a super matrix already, which was from a different one that they already had. So a super matrix is essentially a giant Excel file of sequence data. Like, that's the best way to think of it. Just, oh, I did not mean to click on it. I've used these before. They're pretty solid, but basically I just want to, okay, so where's my methods? Jesus Christ, I'm losing it. Okay, so they had the matrix, they used maximum likelihood and then RaxML to get the topology. Cool. Okay, so let me just write this down. So this one used a used existing phylogeny, ML and RaxML. I think it's RaxML to, I think it's a lowercase a. No, it would be actually, uppercase A, lowercase x. That's what it is. RaxML to get topology. The topology of a phylogeny is basically just saying, like, this one is related to this one, but doesn't really, well, I guess it can be vague, but it usually doesn't have, like, actually how related they are in a lot of cases, unless, you know, just comparatively, like, this is more related to this species or whatever. Okay, so then we then extracted a subclade representing each subclade. Okay, so then they did 174 subclades using Mr. Bayes under relaxed clock model, node age calibrations taken from fossils and estimates. Okay. Okay. The topology was fixed to global maximum. The remaining unsampled species are around the genus overall subclade distribution. One tree from each. Okay. So then, Castus method applied across both clades, across every subclade. Okay. So with this case, I'm realizing Instagram is not the best place for this. It's really hard to show you both things. If you want to see more, pop over to YouTube. Thanks. Boop bada boop 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 boo. Bada bada boop boop boo. Boop bada boop 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 boo. Bada bada boop boop boo. Boo bada boop 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 boo. Boo bada boop boo. Okay. Share. Copy link. Boom. 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 Grafting a phylogeny. Grafting phylogenies over on the YouTubes. Okay, cool. And then I don't have to worry about two screens, and I can just focus on you beautiful people here on YouTube. Okay. Aussie moose for wavy. Got you. Okay, cool. But yeah, we're gonna be chilling today. I'm going to grab my headphones really quick so I can zone out to some music. Yeah, and also, I have somehow convinced my girlfriend, Yasmin, to join us whenever she is all done with everything. Okay, so let me make sure this is all connected good. Bluetooth connected. Okay, it is connected. Cool. So let me just turn on some music for myself, or a documentary. Probably some music. Okay, so let's move this over here. And 8 hours of Stoner Rock. Ooh. You're supposed to be on the other speakers. Boom. There we go. Okay. I'm just gonna turn down these lights. Wow, it's like really dark though. Okay. Oh, actually, this doesn't work because there's spoken words and acid jazz and grooves radio. Okay. Yep, I can work with this. Cool. Okay. So. Okay, finally. Okay, and then each subclade was then grafted. Together, and then rescaled to absolute time. Okay. Okay, so now let's look at what the other phylogeny did. So, squamates. Cool. So here we go. What do we got here? We got 52 genes, 4162 species. So this one used two different ones. Let's hop over to methods. Okay, so combined two supermatrices. Supermatrices. They have their combined data matrix, okay. They then data partitioned. Cool. Data partitioning is where you just assume that different parts of your different genes, for example, different parts of your matrix have different evolutionary pressures, so you figure out which ones are partitioned. Okay. Topology. Use RaxML. Awesome. Okay. Higher level relationships. Okay. Divergent states. Okay. Okay. So, divergent states used in tree, used tree PL. Okay. So, calibrated using 13 fossil-based age constraints. Okay. Okay. So they're both dated, which is awesome. They're both calibrated, which is awesome. Their topology was actually using the same thing. What I'm almost wondering is that how different. Okay, so let me add some questions. Cool. How? You know what? No. Okay. Is it a potential problem to have two different calibration methods over when grafting them together? Also realizing that there we go. Okay, grafting them together. Should I just grab the topology and then recalibrate? Cool. So let's assume that my phylogenies are fine. What we're going to do is we're going to get in both of these phylogenies. So what I'm going to do here, I'm going to copy these. So this is what I have been doing. I've just been binding the trees together, but that's not really the best thing to do. So can I actually let me open up my Stream Deck. This will make this a little bit better. Remind me later. And then we are going to use profile 2. Yes. Okay, cool. So then now I can zoom in for y'all. Cool. Yeah, so I have a few major questions about these phylogenies. So right now I've been binding the trees together, but that's not properly grafting. They need to be recalibrated. So we're going to get rid of this. So right now, these are my 2 input trees. Also, these can be removed. It's fine if I don't have them. Okay, so we're gonna load in all of these really quick. Cool. So now read.tree, read.tree. Okay, cool. So now I have 2 phylogenies. Awesome. So they have the edge lengths, which is fine. Okay, so Okay. So if we look at that web page, grafting phylogenies, the first step is they read in the trees, which is exactly what I have here. So I am also going to, first off, we're going to drop.tip philo raw amphibians, and we're just going to drop the Homo sapiens tip just for the sake of doing that. Okay, so I'm just going to add it to here, to hither. Okay, so this will read it in and then drop the tip. There we go. So we're just going to drop the tip from there. Okay, cool. So now that we have that, so they are creating a tree list. So let's do this. So tree list is equal to, what is the function they're using? Oh, and they're using the package phylools and Geiger. So let me add those here. Okay, library phylools. Looks like I need to, okay. And I need to do that for both of them, okay. I've used phylools before. Oh, I upgraded R recently, that's probably all it is. And then we'll just do, oh, no point. Okay, and then we'll do the same for Geiger. Okay, let me also add this in. Okay. Okay, using the guide from, boom, awesome. Awesome, awesome, awesome. Cool beans. So, Okay, so these are the phylogenies they loaded in. Don't need to do that. Okay, so what they did is they had a tree. They have a list, and it's just going to be a list, and it's going to be, let's call this amphib. Amphib is equal to phyllo raw A, and then we have another list, which is going to be squamate, which is going to be then equals phyllo raw S. Awesome. So now we have a tree list, and then we need to change the class of a tree list to multi-phyllo, meaning that it's a list of multiple phylogenies. So let me also make sure I get this right. Okay. Multi-phyllo. Awesome. So now we have the class. Now we can see over in our environment, we have a large multi-phyllo there. So very easy. Awesome. So now we need to make a tree with different orders. I'm only examining tetrapods, so I didn't have a fish phylogeny include. Okay, so tip.labels, then they make an edge with just orders. And then, okay, so how are they doing this? Okay, what does this look like? Nine, 8, 8, 7, 7, 6, 6, 4, 3, 5, 9, 8, 2, 7, 1. Okay. So edges equal to edge, number of nodes equal to number of nodes. So they're making a tree all the way from the start. Okay. With different edge length measurements. Okay. So realistically, we are just going to make a 2-node tree. In essence, what we're going to be going on is, let's just open up PowerPoint so I can show you this, because I love PowerPoint. So basically, the goal is to make a phylogeny that looks like this, where we have the squamates on this side, amphibians on this side. And then what we're going to do is we're going to have some distance here that says how far apart they were. So that's all. It's a very, very simple tree. So, yeah. Okay, so I need to review edges exactly with a phyllo. Okay, so our phyllo data class format. Okay, there we go. So I just want to double check what does phyllo look like so that I can actually create things a little better. Okay. Trees without data. Okay. So we have different nodes. It's really really what I'm trying to figure out is, okay, so this right here, how is this actually organized? Because if we look at it, it's here. I'm just not sure what the numbers are corresponding to. So that's just what I want to double check on everything. So, number of tips, number of nodes. Oh, you know what? Does this have... Okay, here we go. So, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, let me do, let's just make you... There we go. So here I have 1, 2, 3, 4, 5, 6. So these are the numbers that they have. So they got the edge labels. No. Tip labels and node labels. Okay, I think I'm starting to understand. Realistically, what I'm gonna have... Okay. Okay. This is just gonna be 3, 3, 1, and 2. That's all this is gonna be. Very simple. Very, very simple. Okay, so these are my edges. This should give me what I want, where we have one internal node. Because really what we're trying to take is basically like this part right here where it's 9, 3, 4, right? That's what I'm doing. Like this is what I'm essentially creating. So I should have 2 edge lengths that are going into this. Okay. It's 1, 2, 3, 4, 5. Okay, so we got 274.9 because that's going for 9493. So I need to add in the 2 edge lengths. Okay, which they are using from timetree.org. So timetree.org. So let's do this. Specify 2 taxon names. Taxon 1. Squamate, amphibia. Let's see, or squamata and amphibia. Let's see if it'll work on that. I don't know if I need to add anything more. Nope. Ha, easy. So this one we'll use this right here, this estimation. Although the median is okay, whatever. So we'll just do edge.length is equal to c, boom, boom. So how did that look in here? So they just added it as that minus, okay. Although they all have confidence intervals, let's just use single numbers just in case it gives me issues down the line. I don't want to overcomplicate this. We'll just use 353. R. Okay, 353. That's what we're gonna work with. 353. Cool. So there we go. We got the edges. Okay, and then so they just call it edge.length. Cool. And then we are going to do n node. This will be 2. Okay. And then finally, we're going to call this. We'll just keep it the same order tree. Very inconsistent things. Okay, order tree. And then what we're gonna do is we're gonna say it is a. Here we go. Here we go. Here we go. I want to just make this very, very simple. So tip.labels is all the way up here. Yeah, so I'm just trying to make sure that this is consistent and easy. That way, if we do run into errors with the code, we can just, double check it and alter it. So we got all this, and I believe if we run all of this, boom, 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 okay, that's working. And now we can make a class. Let's just see if this is exactly what we want. Oopsies. I mean, yeah, that's what I wanted. Okay, and then let's add in everything just so that I'm understanding everything correctly. Yep, 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 cool. Easy enough. Okay, I don't need to get rid of fish. I'm keeping fish. I needed to solve. I ran into the error with split age, which means that the earliest node Okay, so they just adjusted the age here. I've already read through this. So the edge length, right. So basically, in the original publication, they put squamates and birds splitting off 274 million years ago. However, the tuatars, which are really cool, they are splitting out about 280. So that's what they used. They just changed the numbers over to 280. It doesn't look like that has shifted anything else. Okay, so we're good there. So then we have the tree list, which is here. Okay, that's already what I have. Now we're at the grafting. Okay. So OTAX. Okay. So they made a data frame that has the class, which are the tip labels, and then a super class. I don't need to do that. I'm not gonna do that. So then they have order tree and OTAX. Okay, wait a second. Here's the tree list. Okay, so then we have that tree list up here. I just call it tree underscore list. Awesome. So then they're adding the class tree. Oh yeah, let's call this class tree actually, because it is not an order. It is a class. It's class amphibia and then class reptilia, technically just squamata, but let's just change all of this. There is a keyboard shortcut to change all these at once too. I just need to do that. Okay. So now I don't think I need to do this. I think I just need to run this right here. Oh, wait. I see what's going on here. So in the class tree, which class tree, oh, class tree is taken order tree and then OTAX. Then the row names. Okay, let me see what this function is doing, because this is where I'm getting a little confused. It's like, how is it going to combine them? So this is from Geiger. Philo. A list of trees to be grafted. Each subtree's element must be a philo with branch lengths in the same unit as phi. Branch lengths in the same units. Ah, okay, so this is what I was needing to double check. So, I'm almost certain these are the same. Let me double check that these are the same. Okay, so. Okay, so what did they use? Divergence times and PL. Okay. I mean, these are both time calibrated, so it should just be time. Okay. Well, let's just see if they'll plot first. Let's worry about one step at a time. Let's put them together. Let us put them together. Okay. So, glomogram, so it needs to go into the class tree. So tree list are the actual phylogenies. So our function should be glomogram dot philo. Okay, so then we have the class tree alongside tree list. So then philo. Could not find function. Did I load these? Should have. Object class tree not found. Oops. Wow, That's a really unintuitive. Okay, so what does glomogram exactly do? Detail. Oh, of course, it's the one you do not tell me. Okay, what is going on here? Cryptobranchoida, extract clades. Okay. Let's see. So we have I think I need to do this labeling step. Okay. Okay. So we are going to edit this. I'm also just going to remove that because we don't need it right now. Okay, so data frame class is equal to, I guess we are now changing this back to order. Class is equal to the tip labels of the order tree. So these are going to actually be, I'm going to keep that as class tree, and we'll just change this back to class tree. Okay, so class tree. So what happens if I do that? Okay, OTAX. I am okay with this. Okay, so then the row names of OTAX are going to be class tree tip labels. And then our class tree is us combining node label phyllo. So just so I could see. So I see this and then error. I'm really concerned that it's because it's only 2. And that's why it's fucking up. Let's split this up into 2 different. Let's split this up into. Let's make this a 3 clade. So let's make it a 4 clade. Fuck it. So okay. Okay. So then. Or I guess 5 clade. Let's make it a 5 clade. Why not? Okay. So we have phyllo. Okay, phyllo salamander. Let's do it right. Pedata, phyllo neura, phyllo urodela, phyllo serpentes, phyllo. I'm trying to figure out how our squamates actually split up, and I'm having a moment. Like, where is the broad split between? Yeah. Okay, it is Serpentis. Yeah, Serpentis and then lizards. We're just gonna call it lizards. Okay. So what we're gonna use is we're going to use this function. I actually think it was listed here. here we go. Extract clade. Yeah, so you just want to extract clades based on the find most recent common ancestor, and then number of phi. What is n phi? Where are they? What is that? N phi is... What the fuck is n phi? Wait, where is n phi? Where do they define what n phi is? Oh, n phi is equal to node label dot phylogeny. Let's look up extract.clade. Basically, I think the issue is node number for the root node of the clade to be extracted. I see. Let's try opening up something in Dendroscope. Maybe we can see the tip labels, or the node labels, sorry. File, open. Let's actually open up these. Let's start with amphibians. Interpret as node labels. Okay, perfection. So basically what we're going to do is we're going to extract from here the node labels. Although these are confidence. Are these the actual labels? I don't think so. Because there's lots of 100s. So these are confidence intervals, I would imagine. Okay, so let's just say I select a node, cool. How about we just extract I don't know. I'm trying to figure it out. I think it's the fact that it's just a double one. But now I'm wondering if, like, based on all of this, maybe there's a way to specify this in bind.tree. Maybe I'm a little bit I'm just trying to figure out how I want to do this. Okay, I just need to find a plot phylogeny. Oh, wait. What are these node labels? Okay, so the node labels are something else entirely. So I need to get... in extract clade, I need to get the node number. Right? Extract.clade. Okay. Name or names of species to be dropped. Okay, node number for the root node of the clade to be extracted. Okay, so can I view... Let's not show node labels. Let's just not do it. Still showing node labels. So let's say I want to see this node. Is there a way? I mean, I guess also what I could just do is, so let's see. So these are, here we go. So this is the options. So oh, right. So I want to like extract this. Is there's a way to do this? Interesting. I mean, I guess what we can do... What the fuck? I just got some random ass message. Oh, it's fucking stupid. Okay. I guess what I can do is I can find the most recent common ancestor of something from this clade and something from this clade. Let's do that. Okay. So let's do Hynobius and Ambystoma. Okay, let's do that. Okay, so we will do, okay, so get, or no, find MRCA of, so we'll do phylogeny A, oh gosh, FMRCA, I was just looking at this, okay, FMRCA, phylogenetics, I'm not sure which package this is coming from, maybe Geiger. How did they do that here? Okay. C, and then I need to do it with, let's do Hynobius abii, and Let's do it with Imbistoma. Let's do Annulatum, because I like it. Imbistoma, and here's an Annulatum. Okay, Annulatum. That should be Annulata, but whatever. Because the Imbistoma ends with an A, so could not find function. Bitch. Oh. Okay, so why would they read? Phi is not a class of philo. Interesting. Class philo raw A. Phylum. Yeah, I was like, I'm pretty sure it is. Phi is not of class phi. Yes, it is. Okay, let's do exactly what they did. So dot MRCA. Okay, and then F MRCA is equal to that. Haha! Cool. So this is how we will extract the clade. Okay. Extract clade. Wait, extract clade of phylora A. Phylora A. So this should just get us the. Let's do it with so these are Caudata. So how is it extract dot clade? Okay, so there's 549 species. Let's now select. That selected all of them. Oop, nope. Okay, Control Shift A. I want to be able to like select down. That's what I'm trying to do. Okay, hold on. I want to be able to like select subnetworks. Oh, do I have to choose that? How do I select these subnetworks? Okay. So then view. Select list selected taxa. That's not helpful. But I'm gonna assume it's all. I just want to know how many labels are in here, how many nodes there are. I mean, no. Okay, so that extracts that. And then you know what I should have done? I should have just extracted. Let's do this a little bit different. Phylogeny non-C Anura caudata, philo. We'll just call it philo and CA, and we'll do that with what, like hyloversicolor or something. Okay. So that should extract that whole clade. And then we need to extract the clade that is this one right here. So we'll do Epicryanops, Ryanops, Marmoratus, and then we just need it to be the common ancestor of a different one. Let's do Cecilia gracilis. Doesn't really matter. Some labels not encounter. Okay, I misspelled something. There we go. Oh, CAE. Okay, cool. So let's just double check this. This should have, if we add up those two species versus Philo Amphibia, how many? We got 4061. And yep, okay, we're good here. Cool. So what we got here is we now have a tree list. So we have amphibian Anura CAU, ANU CAU, which is going to be Philo ANU CAU. I'm going to rename this. We then have amphib CAE, which is going to be equal to amphib philo CAE. Cool. ANU CAU. Okay, cool. We have a new tree list. Okay, so need to have more than 2 phylogenies, so we will split the ignorance. I think in the future I will make this a little bit better, but yeah. So tip labels, amphibian C, and then we also have amphib AC. Cool. Okay, so now it's when we need to change all of this. So 3 is going to split off into 1 and 2. We're going to keep that for AC and C. Then we're going to have another split. So we're going off 3 in there. So let's have a number 4. And then let's have... okay, so actually, let's change these to 4. Let's change this to 5. Let's change this to 3. So that should be good. And then I think this is good. We might need... Wait, do we need one more? Hold on. And then we need it to be... Okay. So 5 is splitting off into 3. Wait. Okay. Okay. So... I need to draw this out. Okay, so what we're going to have is we're going to have another split here. So this will be A and then C. So if we number these 1, 2, 3, 2, 1, 2, 3. If we label this one 4 and then we label this one 5. So realistically, we have 5 going into 1, 4 going into 2, 4 going into 3, and then we also have another one that is going to be 5 going into 4. And then that should give us our edges. Now we need to find the edge lengths for each of these pairs. So let us now go back to our time tree, and we are going to look at it from, okay, so from 5 to 1, that is Amphibia to Squamata. That one will still be 353. So this one needs to be the third entry. Edge.length. Okay, and then what we need in our first edge, which is going to be from 4 to 2. So this is the differences between the Sicilians and okay, so now Cecilia, and let's do Ambystoma. That'll work. I think. Cecilia versus Ambystoma. Okay, 320. So that is fine. 320 between 4 and 3. That will also be a 320. However, now we have 353 for this edge length. So now we need it for this edge length. How does that work? So 5 to 4, what would that edge length? Ah, that's 353 minus 32. Oh, I see. Okay, perfect. Number of nodes, we're gonna call this 3. Oh my god, do I already have it set up right? Okay, so boom, 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 boom. Boom, boom, boom. Boom, boom. Can I just plot class tree really quick? No! I flew too close to the sun. It's actually because I plotted that giant phylogeny and fucked it up. What the fuck is going on with Instagram? That reel I posted has like 20 likes. It hasn't been that low in a long time. Weird. What the fuck is going on with Instagram? That reel I posted has like, what the fuck is going on with Instagram? That reel I posted has like 20 likes. It hasn't been that low in a long time. Weird. What the fuck is going on with Instagram? That reel I posted has like 20 likes. Okay. Oh. Did it delete everything? Did it literally just delete? Oh my god. Oh. was like, it doesn't do that though. What the fuck is going on? Okay. Okay, let's just load in everything again. I can close all these. We do not need every single fucking thing open every single fucking time. There we go. Okay. Boom, 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 boom. Fuck. Okay. Okay. So I have 3 nodes. Oh. Plot clap. Bitch. Nah. Doesn't like that tree. Something's wrong with it, I guess. I suppose. I am confusion. I am confusion. Why does it crash? It shouldn't crash. It's not even that crazy. It's not even that big of a tree, though. Wait. Okay, start back over from the top. It's not even using this tree up here. So we got the tip labels. We got the edge. We have the edge lengths. Okay, what does class tree look like? This makes me so nervous. Like, why is this not working? Okay, hold on. Let's just stop playing with fire for a second. Okay, so then graft, phylogenies. Why? What? What? Why is it crashing? It's such a simple phylogeny. What's wrong with it? Yeah? Okay, so this one has 5 and it has 1, 2, 3, 4, 5, 6, 7, 8 edges. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And so I should have 1, 2, 3, 4. Yes, I need 4 edges, so I have the 4 edges. Okay, so obviously there's something wrong here. So if I'm reading this right, so it's like 6 and 1 should be on here, 6 and 7. 7 to 8, 8 to 5, 9 to 4, 9 to 3, 7 to 2. So if I'm understanding my phylogeny, it should be 5 to 1, 5 to 4, 4 to 2, 4 to 3. And so we have 5 to 1, 5 to 4, 4 to 2, 4 to 3. Three tip labels. Okay, I'm just going to change this to 33. Yo, I am so confused. Why? Wait, why? Our session aborted when plotting Philo. It's an actual ticket. It was just working though, so this isn't like a... Okay. Oh my god. Okay. Let's see if I can plot a different phylogeny. So let's do plot phyllo. Oh, you know what? I can. Boom, boom. Let's plot phyllo CAE. So it can plot. There's not an issue with plotting, which means there's an issue with my particular phylogeny. But I don't know where. Okay. I can't understand why this isn't working. It was working with 2. Is there something fucky? Okay. Fuck. Boom, 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 boom. Edge 4, 4, 5, 5. Maybe I can explicitly call plot.phyllo. No, what the fuck? I don't understand why this won't plot. Let's try. Okay. Oh, wait, isn't there a function in ape to check valid trees? I believe there is. Okay. Ape valid? Check valid phyllo. Okay. We'll start there. Ape check valid phyllo. All nodes should appear at least twice in Edge. Oh, all nodes should appear at least twice in Edge. So then, okay, so that's the issue. But then there's ones like this. 6, 1. The tips are numbered starting at the top from 1. I see that. Starting at the root, I need to delete 1 tip from the tree and 1 node. Oh, but you see they changed it, so 1 is still up there. Okay, it's probably just an order thing. So let's do 5, 4, 4, 3, 4, 2, and then 5, 1. All nodes should appear at least twice an edge. Some nodes are missing an edge. Some nodes are missing an edge. We have 3 nodes. So it starts up at 3. Then we go 2. Then we go 4. Wait, 6 to 4. Wait, hold on. Okay, wait. This is, okay, wait. So to 4, we should only have 9, 4. We do. For 3, we should only have 9, 3. We should have an 8, 9. 8, 9. We should have an 8, 5. We should only have 1 record of 2 at the end. 7, 2. 6 to 1. So if we're going, we should have 5, 1, 5 to 4, 4 to 2, and 4 to 3. I'm just so confused. We only have 3 nodes, right? Like, number of nodes needs to be, it's 2 nodes, not. The root node should not appear in the second column of edge. Fuck. The root node is 5. It's not. What the fuck is going on here? Okay, maybe there's something I'm not understanding. Like, maybe I'm just not understanding it. Maybe there's something, like, really particular about it. Like, I've made these before, so I'm very confused. Let's actually call this what it is, phylogeny. Oh. Okay, I'm going to get rid of all of this. I'm going to load in everything. And then I'm going to, boom, boom. I'm going to load it all in. Okay. And now I'm going to save this. I'm going to save my workspace image. Okay, so that way when it crashes, I don't have to fuck up everything again. Okay. The root node should not appear in the second column of edge. So, my question then is that does this edge matrix need to start, like the first entry needs to be the root node? If we look at this one, we see that 6-1 is that same thing I'm trying to get, and it's at the very end, which is how I have it. Oh god, these are all out of order now. Fuck, 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 fuck. Okay, wait. Okay, so we got 3, 5, 3. What is the root length from 4 to 3? Oh, and then 4 to 2 is 33. No, wait. 4... This is 33, and then this is 320. What does edge look like? Root node should not appear in the second column of edge. Well, I don't have a root node. I mean, I can just add in a new one that's like, 6, 5, and then that one is going to be length of, 0. Sorry, let's do it. Boom, 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 boom. Yeah, okay. I kind of assumed that would not be it. I think it's this order. I think I have the order wrong somehow. So let's see. This one does 9, 4. Okay, so it decreases on the left-hand side. So let's do that. While right-hand side doesn't seem to matter. We'll keep... Oh, 4-4. Hold on. Okay, wait. So I got, sorry, this is switched now. So I got 5-3, 5-2, 4-5. Oh. Thank you. Thank you. Okay, let's switch these node labels around though, just to... So I guess the order is like really, really particular. I never realized that with the edge matrix. Okay, there we go. So that's what I want to look for. And then let's just make sure all of our edge lengths make sense. So what is it? Edge labels? I think I just need to... We'll just add them all on really quick, just so I can make sure I'm seeing everything. And then this is gonna have to be called perfection. Ay, ay, ay. Okay. Well, I learned a lot about phylogenetics now. That's good. Okay. Let's make sure these are all in different orders. Is there a way to just better do this? Node label phyllo. Oh no, let's just do kingdom equals, we'll just call it Animalia. Just be done with it. Okay, I think it's this. So squam. I think the labels need to be identical. It's doing things. Hold on to your butts. This should be a giant phylogeny. Okay, okay, okay. Okay, 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 okay. Bro, I think I got my phylogeny. Okay. So... Okay, well, I do not need to be checking and plotting at all. Let's just simplify this. Okay, so file. Okay, we're going to rename this. Okay, and we're going to call it 1.1 graft phylogenies. Okay, cool. And so then hither we shall say run. No, what is it? Oh my god. Run a script from a script in R. It's probably bad practice though. Yeah, I just know, but I just want to add it in right now. So can I just do that? So source 1.1. Okay, so it'll actually be in scripts /1.1 underscore graft phylogenies.r. Let's just see. Oh, still got plots in here. Okay, and then we will remove all but. Oh, sorry. In R. Ooh, I like this. This is a nice, handy little function. So this is going to remove everything from my environment except for one thing. Ha! Incredibly. Okay. So, boom. And then we are just going to call this philo. And we're going to remove... Actually, we'll keep that. We'll keep that. Okay. So, now that we're at this stage of the research, we will just rerun what I'm thinking is, I think I just need to do this. Rerun it from here. Once these 2 bits of data load in. So you can see I'm loading in 2 data sets I've already made. One is the occurrence data set, which just loaded in, so that has all my occurrence data. And the next one has cleaned data, which is not actually that needed, I don't think, for this, but I just wanted to make sure I do it. So we should just have to... I might run into issues if I just want to... I just want to run it and see what happens. It might run into an error that I'm thinking about. This takes a while to run. I'm going to run to the bathroom while this is running. Okay, we already got the Jacquard's index. Okay, let me open up a new one. Oh, we're getting results. Okay. Open file. File visualization. This needs to visualize. Oh, I was waiting on doing things, but I wasn't. Wow, that Jacquard's index is fucked up. Whoa, that is really fucked up. That should not be that bad. What is going on there? You know, I don't think it needs to be 3. I think it needs to be 1. Let's rerun that. Because that's... wow. Interesting. I mean, I need to rerun everything from the start just to make sure it's all good. Yeah. I need to figure out lunch pretty soon. I might have something in the fridge. Just waiting on this to load up. This should not be this low. I mean, this is like wildly different. Oh! Okay, I was just using the wrong Jacquard's index. Oh, this is so good. Funny, this actually is not let's see, how is this differentiating from my other research? Hold on, I'm looking at some of my results, or looking for my results. Have I never put them into my Notion? I might not have, actually. Let me go to... Okay, let's figure out... Okay. Google Drive, my drive. OneDrive, research, file origin SDSU, going in here, outputs. I should have, I thought I had some pictures. Oh yes, I have my, let's do a different one just to make sure, because I don't know if this is looking right, but it's also looking wrong. But it's also looking right. Okay, let's do it with, sorry, I have some good ones. Yeah, okay. So this is what I was getting last time before I did all of this. Effectively getting last time, and I've made numerous improvements. Oh, it is slightly pulling out. It's different. Interesting. So it's pulling out this right here. There's not as much division here. This around the Sierra Madre del Sur is always going to be good. Let's actually zoom in on it. Oh yeah, 8 is really starting to pull out, which is good. That's what I wanted. Oh! Yes! Okay. Oh my god, you can't even see what I'm really seeing. Okay, hold on. Hold the fucking front door. Hold the fucking front door. Hold the fuck on. Okay, hold the fuck on. I'm also, okay, wait, I think, okay. Some results. Let's nerd out. Okay. I'm also gonna go live on the gram for this one. Okay. So, I have been busting my butt on this very specific analysis for a while now, and I just have been updating shit like fucking crazy, and I finally got some fucking results, and they're showing some real cool shit. So, okay, so, big overview of my project. What the fuck am I doing? I'm doing this method called phylogenetic regionalization, okay? And, okay, so essentially the way this works is that I take all of the species in Middle America of reptiles and amphibians. There's like fucking like 2,000 of them, some stupid stuff. And I take their phylogenetic history, and I'm able to infer regions. So this is my old one. Okay, so this is a old... These are some old regions that I figured out, okay? So this is what I was working with. This is like the stuff I did my proposal on, okay? Very simple. So like we have regions like, oh, okay, the Yucatan in this area. You got some areas down here in like Sierra Madre del Sur. Not del Sur. I forget where it says. Anyways, you know, Baja's pulling out all this other stuff. You got some areas down in Panama. Cool, whatever. But when I made that, I knew there were some issues with my data set. I knew that the geographic data wasn't perfect. I was eliminating a lot of species. I think I had 1,100 in this one, but it should be way higher. So fucked with the code a little bit, added in way more species, figured out some errors that I made. So now it's up to like 1,600. So cool. I added in 500 species, most notably species that are of very small, like ranges. They're not typically found. They're not in museum collections. They're just different. But then I had a second problem. I had my phylogenies. I was doing some bullshit method to combine them. I was just doing bind.tree, fuck it, don't care. Wasn't really looking into it, okay? So, that's what I just finished. I just worked on actually properly grafting them. I had to really do some crazy scripts to make it work in R, and I think I already closed it. But yeah, I've just been working in R to graft all of these two phylogenies together, and it looked incredible. I was like, okay, finally, this looks about right. I'm not even sure which one is working. But anyways, I just reran it, and I got some results. And the results make me happy. Sammy Sosa. Let me show you this. So these are the, zoom. I said zoom. Where are you? Show me. Okay. So these are my old results, right? And these are my new results. Okay, they look similar, but they're different. Similar, but different. Okay. So this is what I need to look through. So there's still going to be issues. I know there's still issues in here, but I was getting really excited because of one particular thing that I'm noticing. If we transition over to our old results, I have been unhappy with region number 7 for quite some time. Been very, very unhappy with it. Why have I been unhappy with it? Because every single paper, including the one that I need to pull up right now to show you what I'm basing a lot of this research off of, every single paper has been showing that region, this region number 7 with like the Yucatan, Belize, Guatemala, all those places, as being split. Not perfect, okay? Like they always, all of them show this. So Savage, 1982, Enigma of Central, this is the main paper, American Herpetofauna. I'm getting better at typing with one. There we go. Okay, JSTOR. Let's open this baby up so I can show you if it... No. Hold on. Can it just open up? Come on. Wait, we're bringing you over here. We're bringing you over here because I am so excited for this. Okay. Come on. Open up. I'm gonna read this later. I'm gonna open that one later too. Come on, open up. Sorry, my accounts are all fucked up. We're just gonna Sci-Hub. Knowledge must be free. Let's just hey, look at that. Wow, I got access to it. How weird. Okay. So, okay, we're gonna zoom out. Okay, so basically this is the paper I've been basing my results off of. So, okay, here we go. So these results, I've been working on comparing them to these results here. So let's see. Let me show you some one-to-one comparisons. This paper from 1982. Okay, so this is what I've been looking at. You see how they take the Yucatan and it's split. You have an area here, you have some little, focus. We have some little regions down below, and that continues down into the more southern parts of Central America, where you typically see a divide right here and then a more north-south split. Okay, so again, this is what Savage was getting, but here is what my old results were looking like, right? My old results were looking like these, where it's all one big thing, and I didn't like that. I still had this north-south split, but it was not really elucidating what I wanted out of these regions. However, the new results are lining up with the original results. Look at that. We're seeing this, the Yucatan, actually following that same pattern. We're seeing this little region here, region number 3, pulling out right here as region number 11. We're seeing this little area, I think it's the Pacific lowlands is what they're calling it. We're seeing that with my region number 10. We're seeing this division right here in region number 12. We're seeing this fuckery going on in the Panama area. It's region 14. So the results are lining up. And this is important because these results have been the basis, the old results, the Savage results have been the basis for so many studies and has not been improved since they were published in 1968. This is 1982, but it's a redone. He's already done this. This analysis was done in like the 60s or the early 70s. It's either 72 or 68, and I'm numbers. Holy fucking shit. Holy shit. Okay. Now there are some issues here though, and I think it's worthwhile to also look at the Jacquard index, so a slightly different one. So Jacquard is a slightly different index to actually get these results, but we're actually getting those same things. So this is Jacquard, and then the next one, it will be Sorensen's. Wait. Oh my god, wait, they're not identical. Hold on. These are not the same. Oh, this is fascinating to me. Why is it doing this? The only difference that I can see, yes, the only difference that I can see is right there in the center. It's uncovering, Jacquard is uncovering a new index. Now the only thing that's weird, that's like I'm seeing as like a potentially major issue, is this right here. These are not splitting out, whereas in my last project they split out into 3 distinct groups based on the mountains out there. I'm not getting that. I mean, I'm getting a little bit, you know, like a little bit of just what the fuck is going on down there. But so these were super clean, these were not. And I think what's going on, my guess is that this new occurrence data I have is showing a lot of species. What's the data for? So this data is based on, what's the data for? So the data is phylogenetic information for the amphibians and reptiles and amphibians. The amphibians and then the snakes and the lizards of Middle America being like Central America, Mexico, and parts of the US, parts of South America. And then geographic data from IUCN and then the Global Biodiversity Information Facility, just like museum records, iNaturalist, stuff like that. And I'm using that data to infer these regions. So they're supposed to showcase regions of shared evolutionary history, right? So for example, this region number 6, kind of that Yucatan area, and then the, I'm forgetting the name of this. It's a particular region that is highlighted in a lot of biogeography studies. So this is like, okay, the reptiles and amphibians here are more closely related in this pocket, this region 6, than they would be to amphibians and reptiles of, you know, the region number 10, for example. So this allows us to like uncover really unique evolutionary history pockets. So think of it as in the olden days, what they would do is they would regionalize the world based on species ranges, right? So you'd have like Wallace's line is a really famous one, where in Southeast Asia, getting into like Malaysia, Borneo, like all that area, it splits it into species of Asian descent and species of Australian descent, and it's right along that line where you can see species from, you know, one side or the other. And that's just how we do it, but it's just based on species ranges. It doesn't account for evolutionary history, so it's always like the dinosaur killing meteor that landed in that area. Yeah, so that area too, like this whole area right here, it's a little bit of a clusterfuck because of these mountain ranges. So you have like the Sierra Madre Oriental meeting down with Sierra Madre Occidental right around Mexico City. And here is where there's actually really big pockets. So if we look at actually, I might have my, hold on, let me show you okay, let me go to Google Slides real quick, because I have I should have some topographic maps on a presentation I gave for this. Let's see, not that one. It might be in here. If not, it's in my proposal, which is very similar to this one. Hold on. Let's look at it. So, for example, these are the zoogeographic realms. Right here, Wallace's line. You see Australian descent, Oriental region, blah, blah, blah. That's also where we get Palearctic, Neotropical, Nearctic. This is where this kind of comes from. But, trying not to get lost in methods. There's so many methods. So yeah, these are my old regions. Haha. Here we go. So yeah, I knew it was Sierra Madre del Sur. So this is an elevation map. Green is lower elevation, red is higher elevation. So I think it'll be best if we show it like this. So if we can, sorry, these are a little bit tricky to zoom in on. And I'm gonna have to remake all these figures. So region 8 here is the equivalent of this 7, 8, 9 that's going on right here. That's kind of this. Um, yeah. So that region's there. That region's overlaid onto here. So that is a elevational range. That's the Sierra Madre del Sur. It's lifting up here. And then there's some lowlands right here, and I'm forgetting the name of it. So, for example, these are what some of the regions we're pulling out of. And then here we have them a little bit more nuanced. So I obviously need to make these figures again, like that, shows. I can actually show this on a visualizer, though. I have a script to do that. But yeah, so it looks like I'll try to follow. Okay, so if we look at 5 here, region number 5, it is kind of along the coast, and region number 4 is bifurcating it. Yeah, for sure. Definitely hit me up anytime. I'm, always nerding out about this, but yeah. So it looks like region number 4 is coming up around here, with region number 5 being down here, and then 9 is being split out, if we're looking at it right here. But, okay. So it's interesting, though, because there are unexpected results and there's expected results. I know what I need to do. Okay, hold on. I need to think real quick. I need to do multiple things. So I do need to do some checks because this is like very early. I just like tossed some shit together. And I need to rerun everything. It's going to take forever. But also not. So yeah, I need to rerun everything. I need to replot this. And I need to double check that everything's good. Hold on, if I go to my com, yeah, so it's 1,633 species. That's what I'm working with right now. Nice. But yeah, there are some early steps that I need to change in here, and then I need to start working on adding more species. Thanks for letting me nerd out. I appreciate you. Goodbye. Ooh. Hit the wrong button. Terrible filming of results, but they be here. Okay, so 2 is all good. No. this little function that takes a presence absence matrix and a region assignment matrix and instead gives a region presence absence matrix. Okay, so for the YouTube people, I need a cup of coffee. And then we're gonna make some functions and we're gonna do some cool shit. Okay, oh, let me finish a thought. Sorry, just saving data. I am so happy I segmented my data. Holy shit, it just made things so much easier. Like, I thought I was gonna have to rerun everything. I only needed to load this data and then save this data to change it. Fucking awesome. Okay, but I need to make some coffee. Cafefe. Okay. Awesome. Oh, I needed lunch. Yes. Okay. I made a really good lunch for me, for meal prep. Did a whole, can't really see it too well, but it's a white bean salad with a risotto. I need to eat the salad, then I can have the risotto. Oh, I'm so happy. Okay, 2 o'clock. I'm just gonna keep going till 5. Yeah. Okay. So once this coffee is ready, I'll explain what these next steps I'm working on are. Get it? It's a pun, because I'm working in R. Okay, so... Okay, this is gonna be sweet. Okay. Oh, this water just needs to heat up already. I also was gonna get drinks with friends tonight, but they had to cancel. So now I'm like, okay, what do I do? What do I do? What do I do? What do I do? it should be pretty easy though, these next few steps. It's just going to be some data manipulation. Oh, and Yasmin is home. Did I just get a message? I did. Recovered some losses. Okay, making the coffee. Okay, just need to start a timer. Oh, Yaz has groceries. I will be back in a second, I promise. So, I was able to successfully graft the two phylogenies together, and then I ran my scripts, and I got new results, and they look poppin'. It's actually, like, I'm like really excited for it. Did I order it white? I don't remember ordering it white. The Lovers. I got a new t-shirt. It's so good. But yes, it looks good. But also bad. There's like good and bad about it.
Do you want me to work with you?
Yeah.
That's fine.
Okay. I mean, I don't think anyone's in there, but I'm about to eat and yeah. Actually, I'm gonna take a break then. Do you want to take a break?